Hi, today we're going to go on a step-by-step implementation of conjoint analysis, and we're going to do this with an example on how to design an optimal restaurant by using information from customers. So let's just assume that you're in a situation when you're thinking about starting a new restaurant and you have different options and you have no real incline as to which one you should choose. And because of that, what we're going to do is we're going to use consumer information / consumer insights to try to decide on what is the optimal restaurant to start. So the first step into our conjoint study is to select the attributes that are going to compose or create our restaurant. And for this, I'm going to focus on what I consider to be the three most important attributes. And the way you select these attributes will be by actually interacting with your customers or potential customers. You can use in-depth interviews for this or focus groups, but there has to be a way for you to get information about what attributes people actually use for evaluating restaurants. And once that you have that list of attributes, you need to pick the most important ones. And I'm going to start with the three most important ones, which are going to be price, menu type or cuisine. What kind of food are you going to be able to eat at the restaurant? Seems to be an important aspect. And then atmosphere, which is whether this is a fancy restaurant or more family oriented. Because having three kids, I think it's important that sometimes you leave the stress of being into a formal situation and just enjoy yourself. So the type of atmosphere is important depending on the situation. After that, we have selected the attributes that we're going to be using for the design of our restaurant. Now we're going to focus on the levels. So for each attribute, we need to select what are the different steps or options that you have for that attribute. So in the case of price, what I'm going to do is I'm going to look at each dish as being really inexpensive, and because of that costing just $5, or maybe being somewhere average by costing about $10 per entree, and then maybe a little bit more expensive by costing $18. And these are just as an example. What you should do in reality is gauge what kind of levels you observe in the marketplace and maybe get a little bit outside of those boundaries to test the waters a little bit, but don't go so either high or low that it will become unrealistic, and because of that people will dismiss the study because they will just think it's unrealistic. Okay, so if you make it too cheap or too expensive, it's probably problematic. Then I have menu type, which I'm going to consider either Italian food, Mexican, or Chinese. Of course, you could have other menu types in here, and that would be fine. These are the three that I have, okay, for the study. And then what we're going to do is the atmosphere. I'm going to only consider two options. It's going to be either upscale or it's going to be family style, okay? Having two different formats that, overall will give you a little bit of leeway into what kind of clientele you will expect and what kind of occasion, right? And now after we have the attributes and the levels, what we're going to do is we're going to take those and come up with all the potential combinations of levels for all three attributes and create the cards that we're going to use to collect the data, okay? So I'm going to show you how those cards will look like in the next slide. So here you have four of the cards that we will use for this data collection effort. So as you can see, all three attributes are mentioned in the cards. If you leave any attribute out, people will make assumptions about the attribute, so you don't want to do that. Okay, and the restaurant will be basically a description based on these attributes. So the first restaurant will have entries that can be purchased for about $5. The type of food that you can get here is Chinese food, and has a family style atmosphere, okay? On the other hand, restaurant 2 will have a price on average about, let's say, $10 per item or entree. It's Mexican and it's upscale, right? So you can see how you can play with the design of the product using three simple attributes, okay? Now, Note that with this design, which is arguably simplistic, but we need to start from somewhere, we will have a total potential number of cards or combinations of 3 times 3 times 2, which is 18 different restaurant concepts that can be designed using these 3 attributes and 3 levels on the first one, 3 levels on the second one, and 2 on the last. So what we're going to do is we're going to take this stack of 18 cards that describe these 18 different concepts of restaurants, and we're going to hand it to our potential respondents, right? Consumers that we think could potentially buy food from a restaurant like the ones that we're thinking about starting. And what they're going to do is they're going to rank order these cards or these concepts of restaurant from the most preferred to the least preferred option. Okay. So let's take a look at the data that we will get from completing this task of ordering the 18 cards. So this is how the data looks like. So here you have the 18 cards that you have collected, right? Okay. And these 18 cards are representing this concept. So you can see here there are some attributes. So we have price, we have menu, and we have atmosphere. So what you're seeing here are the responses from the first respondent, right? Let's see if we can, yeah, here are the responses from the first respondent. So this is the data. This is what we did design, which we call the stimuli, which are the cards, right? So the first card says price of 5, restaurant is Chinese, and atmosphere is upscale. Okay, so this is data, but this is data that we created with our experimental design, right? The actual data that we're trying to ask consumers about is this, which is the preferences. These are the parts that are telling us who likes what. So first respondent, let's see if we can analyze a little bit what's going on in here. So let's look at the restaurant that he likes the most. Is restaurant number 7 here, card number 7. Let's see how it looks like. It has a price of 5. It is Mexican and upscale. So I can understand why a person would like this, right? If you like Mexican food, definitely upscale restaurants are nice, right? And being extremely cheap is definitely something desirable if you can actually pull it off, right? Usually upscale restaurants are more expensive in reality, but if you could have something that it's nice and upscale and sells food for really cheap, who won't go there, right? Especially if you like Mexican food, right? Now let's see what happens. What is this person thinking in terms of trade-offs? So you move from from preferring card number 7 to the second preference is a restaurant that is still cheap, right? Still upscale. So these two things have not changed. But what has changed is now the menu is Chinese. So what we can learn from this data right away, is that this person it's willing to trade off the menu so long as it can have a cheap and upscale restaurant. So he or she doesn't care as much between Mexican and Chinese as he or she cares between a price of 5 and a price of 10. So this person definitely is very excited about getting an upscale atmosphere and an inexpensive price, but maybe cares a little bit less about the actual menu. Let's see what happens with his or her third choice, okay, which we have right here. So again, notice, you see a theme here, right? Price of 5, upscale, but Italian. So you can see the same thing. This person is trading menu, so menu seems to be less important for this person, so long as you can have cheap food in a really nice atmosphere. Okay, so this is the kind of preference that is emerging by just looking at this data. Then where do we go from here? Look at preference number 4. So his or her fourth most preferred restaurant Notice, is Mexican, inexpensive, and family style. So what is happening now is when there are no more cheap and upscale restaurants, this person is happy to switch to a family style. So cheaper food is more important for this person than the atmosphere, because as you can see, he or she is trading off first on the atmosphere um, instead of on price, and definitely prefers Mexican, because if given the choice between all the restaurants, this person is choosing Mexican first over Chinese and Italian for 2 times so far. So you can start seeing that just by doing some cursory analysis of the data, we can start learning a little bit about the preferences and trade-offs that this person is making by just rank ordering these cards. And what we're going to try to do with conjoint analysis is get into a little bit deeper of this data and try to do this analysis that I'm doing here, a little bit casually, a little bit more systematic by exactly estimating what those trade-offs are. Okay, that I was alluding to right now. You can also see here I have data on another respondent, which is respondent number 2, and the preference structure is very different, right? So this person number 2, also likes. Let's see if I can erase some of this stuff. Otherwise, we're not going to see anything, right? So let me erase a little bit so that we can make some annotations. Hopefully, make some sense out of this data. Okay, so what happens with respondent number 2 is a little bit different. Notice that her most preferred profile or restaurant concept is the one that it's in profile 1, which is inexpensive, Chinese, and upscale, right? So you can notice this person prefers Chinese over Mexican, because they could have chosen Mexican, but they chose Chinese. And they like inexpensive and upscale restaurants. So this seems to be similar to what we have had before. But notice what happens now with their second choice. Now their second choice is interesting, because now they move from $5 Chinese upscale to, again, Chinese upscale. So that seems to be a constant. And now the price seems to be less important. So this person is willing to pay more money so long as they can have an upscale experience at a Chinese restaurant. And then notice even further, case number 3, or her third most preferred restaurant, is also a Chinese upscale restaurant, but that charges $18. So it seems like this second respondent is very different from the first respondent. He's very keen on getting Chinese and is very keen on getting upscale, but because of that, is exhibiting a different behavior in not being so worried about the price and be happy to pay extra money so long as they are getting the experience they want. Okay, we can explore for a minute even what happens in his fourth choice. In her fourth choice, we have $5 Chinese family style. So notice this person, so long as they can have upscale, they're willing to pay $18. But if they're gonna go to a family style restaurant, it will also be Chinese. So it seems like they really like Chinese food. And obviously, if they can choose, well, they might as well make it inexpensive, right? So notice that the preference structure between respondent 1 and respondent 2 are very different. And this is what conjoint is going to get us to, is to what degree are those preferences different, and how are these people trading off between the different attributes and levels within this decision about the rest. Now, how do we conduct the analysis for actually getting to these trade-offs and to these metrics? And so what we're going to do is we're going to simplify things a little bit, given that this can get a little bit complex. And I'm going to make some assumptions that are maybe not necessarily always true in reality, but that are going to enable us to at least do some analysis with what we have at our disposal, which is basic statistical tools. So what we're going to be doing is we're going to be using regression essentially to estimate what the utilities are in this preference model that we're doing, which is called conjoint analysis. So what we're trying to do is we're trying to estimate how much utility each of these levels adds to a given consumer. That way we can see how they're trading things off, right? So if we can assign a numeric value to how much they like each of the levels, then for any consumer or for any combination of attributes, we can tell how much they like anything in the marketplace, right? So this will enable us to do all sort of things. It's going to enable us to have a perfect description of their preferences. And because of that, we're going to be able to segment people based on their preferences. And also, we're going to be able to come up with the optimal combination of attributes and levels, which is going to give us our optimal design for the restaurant, right? So what we're doing for this is we are assuming that the utility that any consumer gets from a product is essentially a function of what kind of levels and attributes that product or service has. In fact, what kind of levels, that's it, right? And what we're going to assume is that each level has a unique level of utility for that consumer, which we're going to call alpha, right? So for level J for attribute I, remember we have multiple attributes. In our case, I is either 1, 2, or 3, because we have 3 attributes, which are price, menu, and atmosphere. And then, for example, for price, we have 3 levels. So J could take levels 1, 2, or 3, right? And level 1 will be $5, level 2 will be $10, and level 3 will be $18. So what this equation here is telling you is that the utility that people derive from any restaurant is going to be a function of what levels of the 3 different attributes that restaurant actually has. So what kind of price does it have? What kind of menu does it have? And what kind of atmosphere is in the restaurant? That's all it means. It's just a summation of those terms. That's what this sigmas means. Okay. Okay. So what is xij before? Xij is something that we're going to call a dummy variable. In a dummy variable, the only thing that it does is it records whether any of the cards that the customer is looking at has a particular level. So let me give you an example so that you can see this. Okay. So if you go through your data before, we have a variable called price, right? And let's just say that for the first card, it was 5. And for the second card, it was 10. And for the third one, it was 18. Not that I can draw here very well, but I think you can get the idea, right? Now what x11 will have, we're going to call this a dummy variable, and it's going to represent whether attribute 1, which is price, has level 1, which is a level of $5. Okay, so all this variable x11 does is it checks the price variable. Why? Because it says attribute 1, which is price. Okay, and it's going to check whether it's 5 or not. That's all it is. Okay, so what this is going to be is it's going to be either a 1 when p is actually 5, and whenever it's not 5, this is going to take the value 0. Okay, so in this simple example, the variable x11 is going to take the values 1 and 0 and 0. Why? Because the value 5 on price only appears in the first card, not in the second one or the third one. Okay, so what this is doing is it's translating the information in price into 3 variables, because you will need another 2 dummy variables, which will be x12, sorry, that's a 2, and x13, that will basically record whether the levels 10 and 18 are there. And of course, they will take different values. They will start at 0, right? And then this one will have the value 1 here. The next one will have the value 0 also because of what it is, etc., right? And this one will have the value 1, right? So what you're doing is you're creating 3 variables, which we're going to call dummy variables because they can only take 2 values, either 0 or 1, okay? And you're codifying all the knowledge or information that it's in the variable price, in this case, using these three variables. And the reason you do this is because you're trying to measure these levels of utility for each of the different levels of the attribute. Okay, you'll see that in the results once that we get there. But this is what these variables are. These are called dummy variables. And these can be used in regression, which is what we're going to use to estimate this conjoint analysis. So you have this data that I showed you before, right? And now what we're going to try to do is we're going to try to analyze the data, okay? And the reason, the way we actually analyze this data, at least for this class, although there are other techniques that can be used, is using regression, okay? So what we're going to do is we're going to compute different things based on the data that I showed you before on the slide. And the nice thing is after you do have information on these alphas, which is what we're trying to measure. The alpha, remember, is just the level of utility that each person derives from that particular level of the attribute. So how much happiness do you derive from having a price of 5, right? It's trying to measure that in a concrete number. That's what alpha I j is, right? And what this is telling you in this equation right here is that if we actually get the alphas by just looking at the difference between the largest alpha and the smallest alpha for any given attribute, so for example for price, the difference between the highest value and the lowest value of utility that you get is going to tell you the relative importance of that particular attribute, meaning how important is the attribute. The way you do that is by taking the difference between the largest and the smallest and then computing the ratio, as you can see right here. Okay, so this is one of the first things you get out of a conjoint study. If you can estimate the alphas, which I haven't shown you how to do yet, but I will, then you can compute importance for each of the attributes, which is nice. And relative importance overall, relative to other attributes, how important is one attribute. The relative importance you compute as a ratio, and the absolute importance is just the difference between the largest and smallest utility for that particular attribute. Okay. So in the case of our restaurant example, what we're going to do is we're going to estimate this utility for each consumer using this function right here. As you can see, this is a simple additive function, okay, where we have these dummy variables here that I'm going to underline or I'm going to show to you in yellow, the DPs, right? Those are dummies. That's what in the other equation I call xij, right? And here I'm calling dummies with a D, just, I don't know, just so that it's more obvious relative to what they are actually doing, right? And then what we're trying to estimate that we don't know are the part words, right? Are these betas that I have here, beta 1, beta 2, beta 3, beta 4, beta 5, which are actually the utility levels for each of those attributes. Professor, wait a minute. We are missing one price level. Remember, we had 3 levels for price. And we are also missing one menu level. Why are they not there? Why do you only have, because remember there was a price of 5, a price of 10, and a price of 18. So if you want to represent this with dummies, you will have 3 dummies. The reason why you need to remove one level is because utilities are not an absolute level. They are just relative to a baseline. And because of that, you need to pick, and you get to choose. It really doesn't matter. It's your choice. You get to choose one of the levels for each attribute as a reference for everything else. So all these utilities are relative to whatever you don't put in the model. How much do I like a price of, if in the case of P1 will be a 5? Or how much do I like a price of 10, right? That's what this element is going to estimate for you here, okay? And the way we're going to actually compute or estimate these coefficients, which are the betas, these are the ones that we don't know, which are the utility values, right? It's by using regression, okay? So summarizing, all these somethings, they are dummy variables, right? You have the actual description for each of them in this diagram. So DP1 is for a price of 10, right? So that means that because I have the price of 10 and the price of 18, what's missing here is the price of 5. So what I'm using as a baseline to compare every other result that I'm going to get out of this is the price of what? Of 5. That's what's missing here, right? The same thing here. We have Mexican, and whilst we have Italian, what's missing is Chinese. So our reference is going to be Chinese menu, okay? And again, the same thing. We have here family. So what is missing is atmosphere. So relative to whatever I get out of this model, it's going to be relative to what it's missing, which is an atmosphere of upscale, right? So let's look back at our data, right? So what did we have? Remember, we have these profiles, these different cards we've given to people. There are 18 of them that have this information about price, about menu, and about atmosphere, right? So we have atmosphere, menu, and price. And we have 18 cards that we've given people. And what we're getting back, which is going to be what we're trying to explain, are their preferences. So this is for respondent 1, right? This is the data we're gaining from having then ordered these cards from the most preferred one, which is the one that has the number 1, to the least preferred one, which is the one that has 18, right? Good. Okay, so doing this, now what we're trying to do is we're trying to translate this data set into these dummy variables, right? This is the data that doesn't change, right? But now what we're trying to do is we're trying to convert these attributes that we have in these levels into dummies. So we're going to start with price. Let's take price variable, right? So there are only 3 different levels, right? So there is either 5, a level of 10, or 18. So because of that, we're going to have 3 dummies. Okay, 3 dummies. One for the price of 5, one for the price of 10, one a price of 18. Then we're going to do the same thing with menu and with atmosphere. So let me show you how would that look like in Excel, right? So it will kind of look like this, right? I've cut some of the variables, otherwise they don't fit on the slide. Okay, but remember we have the same thing as before. We have here price, which is what we're going to start with. Okay, and what we're going to do is we're going to create this dummy variable dp1, right? Which is going to take the value 1 if the value of price is 5 and 0 otherwise. Okay, so we're going to go through this price column over here, and we're going to look, is the value equal to 5? The first one, yes. So then dp1 is going to take the value 1. Is the value 5 on the second one? No. So dp1 is going to take the value 0 because it's not 5. Is it 18? Sorry, is it 5? No, it's 18. So now it's going to take the value 0 because it is not 5. The next one, is it 5? Yeah, it's 5 again. So now it's going to take the value 1. Right? So notice that this variable right here has information about this one over here, but it only contains a little bit of the information. It only tells you if the variable for price is 5 or is it not. Okay, DP2 does something similar. Let me change color so that, hopefully we don't get as confused, right? So we have, is it a price of 10? Well, the first one is not a price of 10 because it's 5. So the answer is no, so I put a 0. Is the second one a price of 10? Yes, it is. It's 10. So what I'm going to do, I'm going to put a 1. Is it 10? No, it's not 10. It's 18. So what am I going to do? I'm going to put a 0. Is it 10? Not 10. So I put 0. And on and on and on. Now we do the same thing with the third one. Okay. This will be for the price of 18. We call it DP3. Is the first one a value of 18? No. So what do? I put a 0. Is the second one a value of 18? No. So what do? I put a 0 again. Is the third one 18? Yes, indeed. So what do? I put a 1. And I repeat that process throughout. Let me do one more variable with the next attribute so that you see this repeats with everything. The next one is going to be menu, right? And the first level that we're going to have here, the first dummy variable, is going to correspond to Chinese. So what we're going to do is we're going to check the menu variable, and we're going to see whether it is Chinese or not. And if it is Chinese, which in the first case it is going to be, I'm going to put a 1 for this dummy variable that I'm creating. And if it is not, then I'm going to put a 0. So the first one is Chinese, the second one is Chinese, the third one is Chinese. So these are all going to be ones because it's Chinese, right? Chinese, Chinese, Chinese. Oops, Mexican, right? So all these are going to be ones until we get to the Mexican where it's going to be 0. Why is it going to be 0? Because it is not Chinese. I don't care if it's Mexican or Italian. It really doesn't matter for this. The only thing that matters is that it's not Chinese. And then you do the same thing with the second dummy variable for menu, which in this case will be for Mexican. So because all the first 2, 4, 6 data points in this case are Chinese, they're all going to be zeros, right? And then the first Mexican shows up over here, okay? And then the next one over here. So, and you repeat this with all the variables. So you're going to have a dummy variable for each of the levels. So we have 3 levels for price, 3 levels for menu, and 2 levels for atmosphere, okay? So we have a total of 8 dummy variables that correspond to all the data that we are creating from the cards that we have set up, okay? So we've translated our original information into dummies, which is what we're going to use for estimating the utilities. Now let's see how that would look like in terms of the transformed data. So what are we going to have? We're going to have, if you remember in the original data set, we have the preference data. This is the ordering of all the 18 cards from the most preferred one, which is a value of 1, to the least preferred one, which is a value of 18. What is it? I can't find 18. I don't think 18 is here because I think it got cropped, right? So 18 is probably at the bottom. You just can't see it because I couldn't fit all the data into the slide, okay? But the least preferred one, and these ones that we can see is 17, which is pretty, you know, it's the second least preferred of all the cards that we show to these people, okay? And now what we're doing is we're translating these cards not only in terms of their preferences, which is what we're trying to study, which is the preferences over here, but now we have translated that information into dummies, right? So we have 2 dummies here for price, 2 for menu, and 1 for atmosphere. And if you remember, the reason why we do this is because if we cannot introduce all 3 dummies, the model won't work because all the preferences and all the likes are relative to something, okay? You don't have an absolute number in your head when you're evaluating different restaurants. What you do is you compare one restaurant to another. So price, how much enjoyment you derive out of a price of $10, well, the question is relative to what, right? So what we're going to do is we're going to drop one of the prices out, okay? And the way we do that is by dropping one of the dummies. You can choose any of them, okay? You can choose any of the dummies. The important thing is that you remember which one you drop so that you understand how you set up your relative comparisons. Okay, that's it. But you need to drop one of the levels from all the attributes. In this case, we have 3 attributes. We are dropping 1 dummy for price, 1 dummy for menu, and 1 dummy from atmosphere. Okay. And we're doing one last thing to the data just to keep it more easier to understand from the results perspective, which is the way we reported on the preferences from the most preferred one having a 1. It's kind of counterintuitive to what we do with utility. Usually when you're thinking about utility, you're thinking the more, the better. So more utility means I like it better. But the way we did it here from a coding perspective is the most preferred one got the lowest number, okay? So to basically shift that and change it to the most preferred one gets the highest number, what I'm going to do is I'm going to translate everything from what you have here in this column, that was the original data that I showed you, to just taking this value and then doing 17 minus the value. And no, 17, 19 minus the value. And when you do that, you just basically it changes every value to being just the opposite. So the 1 becomes 18 and 18 becomes the 1. And what you're doing is you're basically now having the same data in terms of order. So the cards will be ordered the same, but now what you're doing is it's like basically moving all the cards, uh, keeping the order constant, but just instead of having the most preferred one first, you have the least preferred ones first. Okay, so that you just what you have here is utility, and it increases in value. So the higher the value here, the most you like it. Here is the opposite. The the lower the number you have, the more you actually like it. Okay, and we're going to use these columns, okay, to estimate our model. Let's see if I can erase some of the stuff that I posted here. I can't. Okay, here we go. So what we're going to do is we're going to take the data right here, and this data right here, not the first column. If you estimate the first column, you just get just the opposite. Everything will be negative where it should be positive, but the results should be the same in absolute value. Okay, so this data over here is what we're going to use to estimate our model, all the stuff that I'm crossing. Okay, so our dummies, dropping one for each attribute, and our preference data, but making sure that higher values correspond to more preferred data, so that it's mirroring what utility that. And this is the model we're estimating. We are estimating that our preferences, our utility, how we rank those cards, are a function of our dummies, and each of those dummies have a weight, which we're going to call B1, B2, B3, B4, etc. And these are our part worths. Okay, how much utility that particular part is worth to a customer. Okay, and the way we're going to estimate those which are not known, the DPs we know. These are ones or zeros that I've already shown you what they are. This is not something you need to estimate. You know what those are. Okay, but what it's not known is what those part worths are. So what we're going to do is we're going to use regression for estimating that. Okay, we're going to use a type of regression called OLS, which stands for ordinary least squares. If you don't know what that means, don't worry about it. It's the simplest type of regression that you can estimate, at least as far as I know. It's just a technique that is used for estimation. I'm not going to walk you through that here. I will briefly post, probably tomorrow, I will post a set of slides that walks you through regression a little bit. Big picture, there is a lot to be talked about regression. So it's going to be a very quick how to estimate the simplest regressions possible without delving too much into estimation theory, because you'll have to take a serious stats class for that. But know that you can actually, with data, which we have the data, that's the cool thing, I showed you the data already, right? So with that data we can estimate these utilities for each individual. So for each customer, I can get the different B1, B2, B3, B4, and B5. Okay, so what we're going to do is we're going to do that. You can do it in Excel. You need to estimate, actually, you need to use one of the packages. It's called the analysis package within Excel that you need to install. If you need help with this, let me know. I will be happy to show you how to do it. But you can actually estimate directly this. In fact, what I'll do is I will post the Excel spreadsheet that you can use to do this. And if you need any help with it, you let me know. But these are the results that you will get right here. Okay, it will give you the results right away. You just need to select the right columns, which are based on the data set I just showed you. Okay, and after you do that, then you will get the answers to what utilities each one of those coefficients represent. So once that we have estimated the model using the data that we have and using regression to estimate that model, what we get as the coefficients of the regression model are actually our part worths. That's what we're trying to estimate from the beginning, which is telling us for each of the levels, how much utility does each of the consumers that we have introduced into the model derive from those levels, right? So how much is worth for somebody to have a price of 5 or a price of 10, etc., etc. So it's going to estimate precisely what that utility is, and that's going to enable us to see what kind of trade-offs are people making, and also it's going to allow us to choose what the optimal restaurant design is, assuming that these people are representative of the customers they are actually going to have. Now we're making an assumption on this, and I'm not going to get too much into details on this, which is that the utility for those levels that we have left out of the equation, right? In the case of price, we left 18 out of the equation. In the case of menu, we left Chinese out, and in the case of the atmosphere, we left the upscale restaurant out of the equation. So we're assuming that those provide a utility of 0 for our customer. Okay, that's just an assumption. If you don't like that number, by the way, you can change it to anything you want, but as you change it, you're going to have to do some additions and subtractions, so you're going to have to impose more constraints. So the easiest number to assume is 0. We need a 0 value anyway. Like I said in the beginning, all the comparisons that people are making are relative. So assuming that a certain value has utility of 0, it doesn't change any of those comparisons if you realize that they are all relative. So you just pick a value. 0 is the one that makes our life easier, so that's the one we're going to pick. Okay, let me show you how the results actually will look like graphically displayed. Okay, so I showed you the coefficients already. Those are the U-tiles. So now I'm going to plot them for you so that you see how those numbers translate into a utility curve. These are actually utility curves, something that you probably have studied if you've taken an econ class. Now we just estimated utility curves based on consumer data so that you can design better products, which I think is pretty cool. But I guess that's just me, right? So let's look at the price. Now notice a couple of things. One is for 18, the level of utility is 0. This is a given because we chose to leave out the price of 18. And you will expect, if the consumer is rational, that it will derive the least utility from a price of 18. Everybody likes to pay less money if you can get the same thing for cheaper, right? So what we see here is that the lowest utility is indeed for the highest price. This makes sense. This kind of confirms that what we're getting at least makes some sense, right? And then we can see how that utility increases by decreasing the price. So when you drop the price from 18 to 10, you gain 8.4 U-tiles, right? And then when you go from 10 to 5, you gain another 6, okay? See that utility goes from 0 to 8.4 to 14.4. Now, if you know anything about utility, this is telling you that there are diminishing marginal returns to price drops, and that makes sense. Eventually, that improvement in utility for having something cheaper becomes less important as the price goes smaller, right? Because, you know, maybe you can trade that with something else, right? So it seems like going from 18 to 10 has a big improvement in utility, but from 10 to 5 maybe a little bit less so, which will make a lot of sense to me, at least just assuming that people are reasonably rational in their decision making. Then let's look at the menu type, right? When it comes down to the menu type, what we left out was Chinese. So Chinese has a utility of 0 again, because it's the variable that we left out. So by design, it has a utility of 0. Okay, and you can see that Mexican, in the case of this respondent, is actually preferred to Chinese. How do I know that? Because the utility is higher than 0, it's 3.7. So I know this particular person likes Mexican better than Chinese. How much more? 3.7 U-tiles, right? And now you can start trading off between these two variables, right? You can see when they are going to shift in menu by looking at how much they care about price. So you can see they care about price more than they care about menu type. So you will expect them, and this is exactly what you see in the data if you're careful and you look at it, that they will not switch type of restaurant even for a higher price, right? Because they care about price more than they care about menu type, right? So they will just like cheap food a lot more than they care about whether it's Mexican or Chinese. And then here you have Italian, which has a utility of 1, still preferred over Chinese, but less so than Mexican. So Italian is kind of in between, right? And then finally, you have atmosphere, which seems to be the variable that this person cares the least about. Upscale, which is what we left out, has the highest utility, has a utility of 0. So this is why I kind of did a funny thing here. The 0 is right here, right? And you just have a negative value. So to not draw it underneath, I just shifted the 0. Okay, and this value here is -1, right? So family is least preferred of the two options for this customer. So they prefer an upscale restaurant. Okay, good. So based on this, now you could create the optimal restaurant for this customer. What will be the optimal restaurant? Well, the optimal restaurant will be a restaurant that will pay, that will be the one that gives the highest utility to this person. So it will have price of 5, it will be Mexican, and it will be upscale. Okay, that's how you design the optimal restaurant for this particular customer. Now, in reality, you're going to have more than one customer. So let's look at another customer. Now, if we do the same analysis for respondent 2, so we estimate another regression model using their data as it's been already shown, right? So we will get another set of coefficients, B1, B2, B3, B4, and B5. Okay, and as you can see here, the utility curve is a little bit different. So the values you get are a little bit different. You still have some commonalities, so you can see how this person, for example, still dislikes, or gets the least utility from a price of 18. No surprises here. Okay, you can see that their jump in utility from going from 18 to 10 is actually bigger than it was before. Okay, and this curve is flatter too, so it barely gains anything from going from 10 to 5. So it seems like this person is less price sensitive than the other one because it gains less utility from going to the lowest price, although this is something to be tested, but it looks to me like it's going to be less price sensitive, so you can probably tolerate a higher price, at least around 10. It won't hurt their utility much. You get almost the same from 10 or from 11. So, maybe pricing at 10 will make sense in this case, right? And then you have Chinese has a utility of 0, right? So I've shifted the 0 is right here. Notice I've shifted the 0 because I had some negative values, right? So you have Chinese has a utility of 0. Italian has a utility of 1.6, right? So it's actually positive. It's above this 0 line that I've created here. And Mexican actually is negative. So I dislike Mexican more than I like Chinese. So I will prefer to have Chinese over Mexican and Italian over both Mexican and Chinese, right? So you can see that there. And then you can see again that upscale is preferred over family. So family has also a negative rating. Okay. So you can see how in this case, I will argue that, yeah, the optimal restaurant will have still a price of 5. It will be Chinese though, instead of Mexican, like in the case of respondent 1. And it will be upscale. But I will argue that given that there is such a small gain here, probably a price of 10 will actually make more sense from a profitability perspective because you will barely gain any customers if they are all similar to this particular profile. So they barely lose any utility from that gain in price, and you potentially could almost double your revenue, right? So you probably in this case will push for a price of about 10 by just looking at the utility curves. Let me just show you how would you compute the importance that I showed you in the slide before. Once that you actually have the part worths, now you can compute importance for each of the attributes. And the way you do it is simple. You take the largest value for that attribute and you subtract from the smallest value. Okay, so for price, what you will do is you will take the largest price. This is, by the way, for respondent 1. You could do this for respondent 2 as well. I'm only going to do it with 1 just to not bore you with this. Okay, so for respondent 1, you take the largest utility for price, which is 14.4. That was a utility you'll gain if the price was actually 5. You subtract from the smallest, which was for a price of 18 and was a utility of 0. So it gives you an importance of 14.4. Okay. In the case of menu, you get an importance by taking the largest to the smallest of 3.7. And in the case of atmosphere, you remember you have a negative value, which obviously is smaller than 0. So the highest value you have is 0, and the smallest value you have is -1. So you get an importance of 1. So you can see if you look at importance across these 3 attributes, the most important one is price. Okay, at least for respondent 1. Notice that for respondent 2, the story will change. Okay, so it's important that you actually do this for all respondents if you're interested. Okay, and then the relative importance, if you want to see how important attributes are across each other, and what you do is you just compute the ratio between each of the importances that we just computed and the sum of all the importances, right, which you have over here, which in this case will be 14.4 plus 3.7, so that will be 18.1, and then 18.1 plus 1 will be 19.1, right? So what we're going to have is we're going to have 14.4 divided by 19.1, which is going to give you 76%. Then menu, the importance is 19%, and atmosphere is the least important. So you can see how much more important in this case is price for this customer. So customer number 1 is very price sensitive. So you need to be careful with the price, especially more than menu or atmosphere. So I'm not sure whether you really want to go after respondent 1 as a target market, because obviously it's all going to be overpriced. Nothing else is going to matter. So it's going to make your life, I think, a little bit difficult in the long term. Right. You could do the same analysis for respondent 1 and see what you come up with. Actually, that will be a good exercise for you to do to make sure that you understand what it is that we're doing.